Hello and welcome back to the lab. Today on the bench we have something from Wavetek, at least that's what I'm assuming, given that someone has apparently been in this unit before and the covers are on backwards. The feet are on the bottom, feet are on the top, and the top is on the bottom. So we're going to have to get in there and correct that. We also have a note saying that something on the main board is pulling down the negative 12 and negative 22 volt rails. So we have a clue as to what's wrong. It is labeled bad, but we're going to see what we can do about that. See if we can't get this 50 megahertz pulse function generator model 166 up and running. First things first, let's get it flipped right side up. All right, we're going to start with giving this thing a good visual inspection. Make sure we don't have any other problems that might be glaringly apparent. Looks like we're missing hardware, a couple of other things. So we'll give this one the treatment if we can. That's an interesting screw. Definitely not the right one. All right, we are on PCB construction. Interesting switches and knobs. Let's take a look at the top side of this board. Ooh, lots of adjustments. This thing might be kind of fun to tune up. Lots of discrete components, transistors. We got a couple of ICs. Nothing too crazy. Definitely some control potentiometers that we're going to service up. These 47 microfarad by 50 volts, these may be a bit of a problem. They're reading quite low, 5K, depending on how sensitive the power supply rail might be. They might be trouble, although they are in the power amp as well, so that's 200 ohms across that tantrum cap. That's going to be a problem. Not a dead short, but not happy either. Yeah, that's 288 ohms. All right, well, our first one that's going to come out is we're going to pull that, let's see, it is C16 out. Get that replaced with something because that is not measuring healthy. Okay, we've got the power supply rebuilt. I did ESR test all the caps, and some of them were starting to struggle a little bit, so I did rebuild the power supply. While I was doing that, I did find 2 wires were flaked off. Actually, 3 wires broke on me while I was rebuilding the transformer, things like that. So right now, the task ahead is I got to clean up all of this thermal paste. We're going to re-thermal paste the pass elements, get them nice and cooled off. I have to clean up this mica spacer. This pops in right here. And we will go see if we get any life back in this unit. All right, I've got the power supply temporarily mounted back in the unit, and we're ready to do some testing. We're going to do this maximum sketch-wise, where I'm going to turn the power button on from underneath. Well, that looks a lot better already. This is a lot brighter. I can tell where the on light is. Let's see, here's our ground. We have a plus 23 volt rail. We have a minus 23 volt rail. Plus 12. Minus 12. Plus 5. Minus 20. Well, that looks very promising. Let's turn on the scope, see what happens. Well, doesn't that look better? All right, so continual sweep. Can give some offset. This thing is not calibrated. Our normal's back. Let's see, our knobs are not lined up, so I'll set it to sweep. Oh, we are sweeping. Okay. I see some frequency sweep. It is really trying to work now. Let's see, triangle waves, those look okay. That's a ramp, that looks all right. Ugh, our square waves look terrible. Square waves look kind of awful, but we can take a look at that. Oh, probably because I'm not terminated in 50 ohms. All right, our pulse looks a little bit better once we're in 50 ohm. Still looks a little strange, but I have to align all the knobs and get some things going because I am sure, like here, let me show you. Our pulse width variable knob, that's set to 1 microsecond. That should be 100 nanoseconds, 10 nanoseconds. That should be the end of travel. Nope. Still going. So this knob is way off. Actually, there we go. We got square waves now. So on the slower side, with the pulse width, we have much better square waves. Oh yeah, these knobs are way off. Okay, so next step. We have some semblance of sanity back in the unit, and it is working. I got to get some actual hardware. There's a bunch of screws and stuff that I have to replace, get back up here. There's probably a couple of more electrolytics I'm going to replace on the board. You can take a look at this board. There's a couple of more electrolytics I'm going to replace. Let me turn this off because I'm going to stick my fingers in there. These guys will probably go. These guys will go for sure. These polys are probably all right. All the controls need a really, really good cleaning. And then we'll try to work on doing an alignment. I was able to dig up a service manual, so I do have, you can see the sea of potentiometers that have to be set in this thing. And hopefully, we may be making some progress. When I do reset all these buttons, I'm going to give the front panel a good wash. Get that all cleaned up. But I'm not unhappy with that. All right, that front panel looks quite a bit better. I had to redo pretty much every control on the front of this thing. I don't know what happened to this before it hit the bench here, but every single control was not in the right spot. So that would have made troubleshooting entertaining, if not impossible, because what you think you're setting the front panel to, nothing's working. So next thing I got to do is I got to get the power button put back in, which means I'll have to pop the power supply off and then put it back on. Not a huge deal. And then we'll see what the switch cleaning did. All right, after setting up the knobs for something that resembles sanity, we even have sweeping. So I still have some problems on the square wave side of things on this particular unit, but I am getting decent edges. I checked the rise time on the square waves, and I should be getting 7 milliseconds or 7 nanoseconds by the front panel. I'm getting 5, so we're beating spec. Still got to work on cleaning some of these controls. The controls are quite cranky, and I still have to do some tweaking with the knobs because they're not, even after I went and reset everything, they're not quite set exactly correct. So, especially the edge knobs to get it to make sense. So that is causing some issues with the circuitry. So all in all, not unhappy with how we're sitting. And I'm going to let the switch cleaner sit and do some more work. I got to fiddle with all the controls a bunch more. But we're also going to do some burn-in testing. Just let it sit, make sure the power supply doesn't have any other big issues. But where we're sitting right now on this Wavetek, I'd say 80% there. So, not looking too bad. Well, it's not a Tektronix calibration, but we have a table with a bunch of steps, 43 to be precise, and a whole bunch of checkpoints and some various gear that we need to adjust this Wavetek. They want a DMM or a DVM or a differential oscilloscope with 500 megahertz of bandwidth. We've got that. I need a distortion analyzer to 600 kilohertz. We do have that. And a frequency counter to 50 megahertz. But I don't have the distortion amp on, or the distortion analyzer on, so I need to get that warming up as well. Okay, we will start with the power rails. Here's a ground point. Test point 1 should be plus 12. $12.6. And that we want, the unit wants some adjustments, so let's hook up some clip probes and get a better grab on that. This way you guys can kind of see how the action's happening. We have let the gear go through a proper warm-up. We're at 12.6, so we're running a little hot. They want plus minus 50 millivolts. So our 12-volt adjustment is right here. We actually need to come down a bit. Oh yeah, lots of adjustment. Need a better tool. The angle on this kind of sucks. $12.00. As you guys can see in the meter, we'll bring this down. Can't complain about that. Negative 12 will be test point 2. Test point 3 and 4 are the plus 22 volts. They are actually over here, and the way I've installed those capacitors is going to cause me a pain in the butt. So I'm going to turn this sideways, and we're going to get at that from the bottom as the bottom cover falls off. We are measuring these at the decoupling caps for the power amp. So we actually have a decent voltage across the two because it's a plus minus supply. There's 22.1. Looking good. Negative 22.1. My tolerance on that is 400 millivolts. No problems there at all. I'm being extremely careful moving this thing around, knowing where all the 110 is, so we don't blast ourselves into orbit with the mains. Test point 5 is the 5.2 volt, and if I do need to adjust that, which I probably will, it's R24. Test point 5 is this capacitor way back here. At test point 5, we have 4.99. We are within the 20 millivolts tolerance. Oh, no, we're not. We need 5.2. So that's going to need an adjustment. Doing this with clip leads is advised. We are also going to do this with a insulated tuning tool because I do not know if this heatsink is at any potentials or not. So I will always assume the worst. We need 5.2. So we had to come up about 300 millivolts. 210. 5.19, that won't be a problem at all. Okay, letting the unit warm back up. I did notice I did not have my chassis ground connection connected, so I got that hooked up with a proper gas-tight washer. Okay, on the step 6, the hysteresis switch balance, the test point is on this resistor right here. The adjustment point is here. And if we take a look at the scope, we want to adjust the balance to 0 volts plus minus 100 millivolts. So if we ground out the scope, we're right on 0. And then if we kick it up, there we go. Oh, that wasn't measuring correctly. Nice. I'll have to adjust that a bit. Scope's not playing nice. And that's balanced right at 0. I'm using the zero and 100% gradical on the scope, which is working well for this particular measurement. Okay, checking test point 8 for a DC offset of 0, and we're at, that could be tweaked a little bit, but it's not bad. It's a division 2.5 on the scope. So we need to tweak R31. It is on the bottom board, all the way at the bottom. That's going to be good for our DC offset. It's now a division and a half each side. Back to the DMM for test point 6. It's actually kind of hard to find. And this wants generation mode goes to triggered. Waveform should be square. And we're looking for 0 volts DC plus minus 5 millivolts. I'm at negative 50, so we need to adjust R86, which is right here. Quite touchy. Wow, tolerance is actually pretty tight on that one too. All right, we're at negative, we're at bouncing between -5 and 0, so that is going to be good for that one. That's what the reading is at test point 8. Okay, with the output vernier all the way down, fully counterclockwise, we want to adjust R330 and R334 for as close to DC as we can get. Well, that looks pretty good because we're at 50 millivolts per division. So that's not too bad. 330. The potentiometers being adjusted are 330 and 334. Oh, can't see because of my hand. 334 and 330. These are the two pots that we're tweaking. R46 is the time symmetry. I use the Rigel, pressing the Rigel into service, and then actually adjusting for duty cycle to get it to 50%. Okay, we tune 142 and 103 for the lowest distortion. We'll go back and forth a few times. So our 216, 226, and 238 are fixed resistors, but it looks like with adjustment, pardon the camera movement, we got 1% THD. Not too bad for a unit of its age. And that is 1% THD with all the filters out. So we're using the full bandwidth of the AA501. Okay, we're checking for DC offset between normal and inverted mode. Amplitude changes is okay, but we don't want to see the waveform shifting up and down. And that looks pretty good for the sine wave. Triangle wave. Also quite good. Square wave. Don't need to check the square wave. But we're at 2 volts of division, so 200 there. Yeah, that looks fine. It's calling for a differential scope, and I don't have one handy, so we're going to flip back up to the Rigel again, and we're going to adjust 248 to the positive and negative peak voltages are within 20 millivolts of each other. So I'm actually looking at min and max, and also top and base. So I want top and base to get real close to each other for the output amplifier zeroing, which is 248. They're off by about 15 millivolts, so I will take that. Now we flip it to square wave. And our V-top and bass are actually good as well. Quite good, in fact. They're hitting exactly where I'd like them to be. 499 and negative 492, and I have a 50 millivolt tolerance. All right, we'll come back down to the 7103 because it's easier to see. I have the square wave waveform plugged in, and we're looking at the rise time lines because it's convenient. And I'm looking for DC shift, which we have a bit of DC shift. Actually, we have quite a bit of DC shift. I need to adjust 203. It's not balancing well. That's about as good as we'll get it. That's not too terrible. Yes, that's not bad. That's checking the 0 volt on the pulsed wave. Yep, that's fine. Pop back up to the Rigel for the amplitude measurement on sine wave. Let's see here. We're going to get pretty good signal here. Amplitude, I got 28.8 volts. And 15 volts peak to peak. Okay, for the haver, we have the sweep out and the trigger in hooked up, and we're getting a burst of triangle wave, so that is working. We need to check the VGC null, which is going to be a frequency counter. Okay, everything is, when I'm shorting the VGC in, or VCG in, we don't have any frequency shift, which is what we're supposed to have. So everything is good with the VGC null. Okay, our linear and log functions look okay. That's in linear mode. That's in log mode. 1000:1 time symmetry looks good. We'll go to 1K and 5. Time symmetry looks all... Could use a little bit of tweaking. 46. Now we have a 50% duty cycle. Frequency is 0.5 and 1 meg. Duty cycle looks all right, but we can tweak 47. That's stabilizing all right. 0.5. 10 megahertz. And duty cycle's at 50%, which is good, which is perfect. Nothing to mess with there. Frequency. Flip this over to the TTL out. Okay, this should be 5 kilohertz. It's a little hot, so we need to adjust R13. R13 is actually the master clock. That's all right. R18 for 500 hertz. That looks good. And 50 megahertz is looking all right. Tweak R15 for 1 megahertz. Or 5 megahertz. Mm, 5 megahertz is a little light. Uh-oh, lost my tab. Not too bad though, because my it's plus minus 10 kilohertz, so I am still within specification. 100K. R16. Very much not bad. Tweak this up a touch. Really, really not bad. 10K. 50.1. 10K is R17. Tweak this down just a touch. Not going to complain about that. R188. 50 hertz, not bad. Need to come up just a touch. But I also need to check that duty cycle. Duty cycle looks all right. For the logarithmic side of things, everything else is more of the same, and it is very repetitive. So I'm going to do that, but I'm not going to do that on camera. The logarithmic frequency, it actually says to repeat steps 24, 36, and 37 several times to get the log right. So we will go ahead and do that, and I'll come back with the high frequency waveform. Okay, we're getting out the high speed scope and taking a look at Step number 39, we have our step response of 10 volts. I have the 11A72 AC coupled, just in case we have some DC offset. And we're pushing the scope about as hard as I want to push it, given it's a 1 gigahertz input. And this calibration routine wanted 500 megahertz, so we are well above what we needed. But let's see what happens when I tweak our 266. Well, that improved that step response. That looks pretty good about there. So I want sharp rise, and then I don't want any bobbling up at the top. That's what we're going for, is a good step response. We should be able to measure our rise and fall times. So our rise time is about 5.1, and our fall time is about 4.8, which isn't too bad, but we do have some. So what does 285 do? No. Not doing much. We'll expand this out again. Yeah, 285 is good. 351. Ooh, that's very much our aberration, so we don't want to do that. So right about there is going to be good. Okay, so the sweep output no load, ramp sweep positive peak looks good. And we'll dial it this way. Take a look at the bottom peak. And the bottom peak is slightly rounded, which is also good. Top peak is slightly flat topped, which is good. That is what we're looking for. Okay, the last sweep that we need to check is the DC offset, which would be R62. And we are looking for a 0 volt offset. I have the sweep lined up at the bottom line. We're going to hit DC, and it stays there right at the start. That's a 50 volt. Yeah, so we are good on the DC offset. So the last part in this procedure, the final calibration, which is optional, is close the covers, warm up the device for an hour, and then repeat steps 11 through 28. So essentially, let it warm up, do the whole thing again. We did give it an appropriate warm-up time before we got started, so everything should be good to go, and I'm not too worried about it. I'm going to get the covers put back on, and we're getting close to calling this one done. Thanks for stopping by the lab and taking a look at this Wavetek Model 166. This particular function generator has a home that it's going to go back to, but I do have a bunch more of these in the queue. So if anybody would like one of these units, let me know, and I can send you some pictures and see what we can make happen. If you guys would like to check out a little bit more content, patrons are running about 4 videos ahead right now, 5 videos ahead right now. Everything will eventually end up on YouTube, but the support of the patrons does help bring videos to the lab, get equipment on the bench, things like that. Really helps me get some things going so I can get videos up to you guys. And I do appreciate every single one of the patrons' help. They help far more than people know. So with that, as always, more is on the way, and I will see everybody in the next video. Bye for now.